Okay, this is another user submitted limit they asked me to do, and like I said, I usually don't do this, but why not? I haven't put out a video in a while that I've made public. Well, I've made several for my own calculus students, but anyway, here we are. Limit as x goes to 9 of the square root of x minus 3 divided by the quantity x minus 9. And first thing we do is we look at what happens when we just plug in the number. If we plug in a number and we get a number, hey, it's good. We can go from there. If we get an indeterminate form, then we got to do something else, right? So square root of 9 is 3. 3 minus 3 is 0. 9 minus 9 is 0. Hello, we got the 0 over 0 form that's indeterminate. We don't know we can't fix this, so we don't know what we can't really say anything at this point, so we have to do something else. Again, we could do L'Hopital's rule on this, but if you don't know that yet, then you got to do it the old-fashioned way. And in general, now this is not technically a rational function, because why? Because, well, the square root of x minus 3 is not a polynomial, and a rational is clearly defined as a polynomial divided by, or the ratio of polynomials, or a polynomial in the numerator and a polynomial in the denominator. And the square root of x, is, although algebraic, is not a polynomial. So in general, notice I say in general. In general, when we're taking limits and we have an expression like the square root of x minus 3 over something, or even something over a radical expression plus or minus something, we multiply by the conjugate. Well, we multiply by 1 in the form of the conjugate of the expression wherever the radical is. So the conjugate of x, square root of x minus 3 is square root of x plus 3. And then we just do our square root of x times square root of x is x. And we know the middle term cancels out. Square root of x times 3 is positive 3 square roots of x. And negative 3 times square roots of x is negative 3 square roots of x. So the middle term cancels. And then we're left with negative 3 times positive 3, which is negative 9. And then the bottom, now never multiply out the bottom. At least that's what I was always told, and that's what I tell my students. Until, I mean, I guess in some instance, I shouldn't say never. I've never ran into one, but maybe there's some instance where you would want to multiply the bottom out. But in general, when you do this process, you don't want to expand the, you don't want to undo the work that you've already done, because really what you're going for is this right here, where you have this factor of x minus 9 in the numerator and x minus 9 in the denominator. So those, of course, will cancel. You're left with a 1, not a 0, as some students seem to think. Left with a 1 in the numerator and a square root of x plus 3 in the denominator. So now, once again, we'll look at the form of the limit, or form of this expression when we plug in a 9, see if we get a number, or if we get another indeterminate form. So we get square root of 9 plus 3 equals 1 over 3 plus 3 equals 1 over 6. That's a number, so that is the limit. Again, I'll show you the L'Hopital's rule way. We have the form 0 over 0. I'm just going to go straight to L'Hopital's rule, just take the derivative. This one's a little funny because some people have a problem taking the square derivative of the square roots. But if you know anything, we know the square root is x to the power of 1/2. So I'm going to erase that LR because I haven't actually taken the derivative yet. I like to put that when I do. So now I'll put my little LR. I'm going to take the derivative of the top and the derivative of the bottom, and then take the limit. The limit of x to the 1/2 is 1/2 times x to the negative 1/2. Derivative of negative 3 is 0. Derivative of x is 1. The derivative of negative 9 is 0. And I'm just going to clean this up because I don't necessarily, it doesn't, even as long as I've been doing math, I guess I could say that I think about it, but really the negative exponent does not say denominator to me. I know it because it's a rule, but when I'm looking at it like this and I'm taking limits, it does not say denominator to me. So I'm going to put it down in the denominator, and I'm going to reintroduce the square root because I like it. So now when I plug in a 9 in for x, I get 2 times the square root of 9, with square root of 9 is 3, 2 times 3 is 6, and of course I come up with the same answer. So that's just L'Hopital's rule way. I don't know why I decided to do it that way. I guess because it is a user-submitted limit, and they didn't really tell me which way to do it, so I did it both ways. But generally, I assume if you knew L'Hopital's, you probably wouldn't ask me the question. So anyway, there it is.